Okay, there we go. All right, so today's lesson, we're going to be investigating the unit circle. Just a reminder, why is it called the unit circle? It's called the unit circle because the radius is 1 in this unit circle, 1 unit. It's just a reminder. Many of you have already had experience with the unit circle last year. Some of you may not have. It's okay. So I'm going to start and explain it all over. So cosine is mapped to the x value on the unit circle, and sine is mapped to the y value on the unit circle. That's just something you actually have to memorize, that cosine is x and sine is y. I remember it by alpha order, right? C comes before x, before s, cosine, sine, x, y. That helps me remember which is which. But that's just something like you got to just commit to memory. So I'm going to move this over here a little bit because I got more stuff to do. So cosine is x and sine is y. All right. For the 30, 60, 90s, so this is the 30, 60, 90 triangle. So let's kind of investigate those strands. So we've got, here's one, green, let's see, so, okay, we've got this one, there's two strands in each quadrant, 30, 60, 90 strands in each quadrant. Okay, 30, 60, 90s. And 30, 60, 90s will only have one of these two numbers associated with it. Actually, I have both, but in a different order. Root 3 over 2 or 1/2. I mean, that's all there is. There is no other number. Root 3 over 2 or 1/2. So when you are deciding where to put them, so let's do some numbers. So root 3 over 2 and 1/2. Which one of those numbers is larger, root 3 over 2 or 1/2? Close. Root 3 over 2 is larger, so this one is larger. So why do we need to know that? Because, like for example, here on this 30-degree angle, this is longer along the x-axis. See how it covers more of the x-axis than the y-axis? That's why, since the x-axis is longer, the x-coordinate is the larger number. The x-coordinate is root 3 over 2. Since the y-axis is shorter, the y-coordinate is the smaller number. Okay, so let's look up here at this 30, 60, 90. All right, this one is taller. The y value should be the bigger number because it's taller. So I'm going to put root 3 over 2 here for the y value because it's taller. It's not quite as long. It doesn't go as long along the x-axis, so that's why that number is smaller. Okay, does everybody understand the rationale for why the numbers go where they go? Now, once you have that, you just have to reflect it all to the other green lines. There's nothing else to memorize. Nothing. It's either root 3 over 2 1/2 or 1/2 root 3 over 2. That's it. The only thing that changes is the sign of the number depending on the quadrant. So let's go down here. We would take this, and this reflects right down here, right? We reflect that one down underneath the x-axis. So it's the same values, root 3 over 2, 1/2, but they're both not positive. Which one is negative, the x value or the y value? The y value. So the y one I need a negative by, but it's still that same pair, root 3 over 2, 1/2. Okay, let's go directly across.
Wait, what if both of them are negative?
What's that?
Oh wait, sorry, no.
It's okay. Okay, so let's go straight across. Let's go this way. Okay, it's still going to be root 3 over 2, 1/2. Still going to be root 3 over 2, 1/2. But are they both still positive? Is x and y positive in the second quadrant? No. Which y is still positive, but x is negative, so it's going to be negative root 3 over 2, 1/2. And the last one, so we're going to reflect down right here. And so we've got, again, root 3 over 2, 1/2. What about the third quadrant? What are the signs of x and y in the third quadrant? They're both negative, so both of these numbers are negative. So it's just a pattern. Once you know the first quadrant, you can just reflect. Let's take care of this one. So let's look at this one up here. Let's reflect this one down here. Okay, let's reflect it down. So this is 1/2 root 3 over 2. And we decided that y is negative. So the root 3 over 2 would be negative. Okay, let's reflect it across. Reflect it across. We see that it's still 1/2 root 3 over 2 because of its location. But in this case, x is negative and y is positive. And the last one, we reflect it. We go reflect it down here. We're just continuing around. We still 1/2 root 3 over 2. And they're both negative. So that's 30, 60, 90s. All right, let's work on, so I'm going to pause there for a minute. Is everybody okay on that pattern? Do you see how it's the exact same numbers, just in different orders and different signs? There is nothing else to it. Okay? All right, so let's move to 45, 45, 90s. So the 45, 45, 90s are these right here, right? There's only one in each quadrant. Let's see what, let's do pink. So there's only one, there's this one, there's this one, and this one, and this one. Okay, one in each quadrant. Now, the thing about these is they're always root 2 over 2, root 2 over 2. There is no decision to make except for the correct sign. That's it. Just the correct sign. So as we go down here, it's just root 2 over 2, root 2 over 2. It's the fourth quadrant, so we know that x is positive and y is negative. Over here, it's just, root 2 over 2, root 2 over 2. We know in this case, y is positive and x is negative. And then root 2 over 2, root 2 over 2. These are kind of boring, right? These are both negative. So the 45, 45, 90s should not be hard for you. It is one number that's duplicated. It just changes signs depending on which quadrant you're in. So I'm going to pause there for a second. Is everybody okay with the 45, 45, 90s pattern? All right, so the last thing we need to talk about is the quadrantals. Do you remember that vocab word from earlier in this week? Quadrantal, what that means? It's the x and the y axes, the quadrantals. So if we look at this point right here, this is 1, 0. So x is 1, y is 0. So this would be, sine would be 1, y would be 0. It's just a coordinate point. This is just, we've been doing this kind of coordinate point for years, right? This is 0, 1. So we know that cosine would be 0 and sine would be 1 because x and y. This point is negative 1, 0. So that quadrantal is sine is negative 1 and cosine is 0. Excuse me. Sine is negative 1. Yeah, cosine is 0. And the last one, that one is 0 along the x-axis and negative 1 along the y-axis. Okay, that's all there is to the coordinate points and how they're related to sine and cosine. Questions so far? Okay, so once you have the points down and know where they are and how to figure it out, and we'll work some problems where I show you how I work it, and hopefully that will be helpful. But the other thing that typically confuses students is radians. So I'm going to go along, we're going to talk about radians and how we populate the radians on the circle. So here we go, we're going to work on the 30, 60, 90s. For the 30, 60, 90s, we count by 1/6. That's what we count by, is 1/6. And there are, there are 2 in each quadrant. 2, 30, 60, 90s, they hug each of the axes. So this would be 1 pi over 6, So I count and by 6. 1 pi over 6, 2 pi over 6, 3 pi over 6, which is the quadrantal, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, and if I wanted to, I could say 12 pi over 6. Now we would need to go through and reduce them. So this 2 pi over 6 is pi over 3, 3 pi over 6 is pi over 2, 4 pi over 6 is 2 pi over 3, 5 pi over 6 is reduced, 6 pi over 6 is pi, 8 pi over 6 is 4 pi over 3, 9 pi over 6 is 3 pi over 2, 10 pi over 6 is 5 pi over 3, and 12 pi over 6 is 2 pi. So that's just the reduced form. But I am seriously just counting in sixths. That's how I do all of it, just like that, because I need a pattern. I need a pattern. Some of you may be just great at memorizing and you don't need this pattern at all. You're like, I don't need that. That's fine. I need a pattern. So for the 45, 45, 90s, 45, 45, 90s, we count in 1/4. So there's 1, 45, 45, 90 in each quadrant. Okay. So we have 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and 8 pi over 4. Okay, so we just counted in fourths. So 2 pi over 4, of course, is, pi over 2. That's already reduced. 4 pi over 4 is pi. That's already reduced. 6 pi over 4 is 3 pi over 2. That's already reduced, and 8 pi over 4 is 2 pi. Okay, I want to pause there for just a second. Okay, so that's how we count the radians. I mean, I have done this for a very, very long time, and I still count them this way. If you ask me where, 5 pi over 3 is, I would need to count around to get to 10 pi over 6. I mean, I would just need to. That's how I do it. Okay? So we've talked about the coordinate points and we've talked about the radians. So this is just something that you're going to be working on memorizing. You're going to have several weeks to do it. It's going to be fine. Okay? All right. So let's look over here. I've got a few more things on the other side. This, these ratios, the SOHCAHTOA thing you've been working on since geometry days, right? Sine is opposite of our hypotenuse, cosine is adjacent of our hypotenuse. That SOHCAHTOA thing. We're going to be looking at that today. What you might not be as familiar with is the reciprocals. So the reciprocal of sine is cosecant, which is just so wrong. I wish the S's matched up in the C's, but they just didn't do it that way. The reciprocal of cosine is secant. The reciprocal of tangent is cotangent. And reciprocal means it just flips upside down. Just flips upside down. And these are ways to write. Cosecant can also be written as 1 over sine. And secant can also be written as 1 over cosine. And cotangent can also be written as 1 over tangent. Just a different way to write it. Just when I want to turn it off, it stops. It must know. It must know, like, oh, she's getting ready to turn it off. I don't know. Okay. Is everybody okay with that? And tangent, just a reminder, tangent is sine over cosine. If you don't know that, you definitely do need to know that. Tangent is, so sine is y and cosine is x. Tangent would be like y over x. All right. Let's go to our second page, which has some problems on it. Okay, is everybody okay? Okay, great. So here we go. I find the exact value of the function. Here's what I do. I'm doing my unit circle thing. I'm going to write this down. So 4 pi over 3 is 8 pi over 6. So I usually count with like dots. I'll do like 1, 2, 3, 4, 5, 6, 7, 8. 8 pi over 6 is going to be right there. Okay, so I need to think about it. Now that's third quadrant, so our answer is going to be negative, right? It's negative. Let's see, it's longer along the y. So it's longer along the y, and we want the x. So we want the smaller number, right? It's longer along the y, so the y is going to be the bigger number, and the x is going to be the smaller number. And so what is my answer? Negative 1/2. Very good. That's how I do all my unit circle stuff, just like that. Okay, tangent. We just talked about tangent. Tangent is y over x, sine over cosine. All right, so let's get to 60 degrees, which would be right here. Okay, that's longer along the y, so this is 1/2 root 3 over 2. Okay, that's the coordinate point. I'm going to pause here for a second. So 1/2 root 3 over 2. So I need to make a fraction. I know y'all are going to be so excited about this. These complex fractions, we love these. 3/2, 1/2. Remember the whole keep, change, flip? Keep the top, change to multiplication, and flip the bottom. Luna, go ahead. We're just going to turn it off, if you don't mind. Thank you. It had a chance, right? We gave it a chance. It's like, nope. All right, so keep, change, flip. So I keep the top. I know a lot of middle schools teach it that way. That's why I'm saying those words. Keep, change, flip. Change division and multiplication. I flip the bottom to 2 over 1. The 2's cancel out. So my answer is root 3. Okay, we okay? Okay, great. So now let's go to number 2. And we want to find the 6 trig functions. So what are they talking about? They're talking about these. So there's 1, 2, 3, 4, 5, 6. They want all of those. That's what they mean by 6 trig functions. They want those. So let's figure out what they're talking about. Terminal side passes through 5, negative 5, 2. Okay, let's draw that. So negative 5, 1, 2, 3, 4, 5, 1, 2. So I got a point there. Let's remind ourselves what terminal side means. So if you recall, this is the initial side, right? The initial side is on the x-axis, and they're calling this the terminal side. Okay. I can't even draw a straight line. Okay, go with me, ladies. This should be a straight line. Okay, let's pretend. Let's pretend that's a straight line. I'm going to drop this down and create a triangle, a right triangle. Why would I do that? Because I'm going to calculate SOHCAHTOA off of my triangle. SOHCAHTOA off the triangle. So this is theta. This is a negative 5, and this is a 2. So we go back to our geometry days of Pythagorean theorem, and we do negative 5 squared plus 2 squared equals c squared. So 25 and 4, what is that? 29. So this is the square root of 29. By the way, some students get quite confused. I want to make sure we understand the hypotenuse is never negative. You might write that down. The hypotenuse is never negative. How do we get the hypotenuse? We square two numbers. Is it possible to square a number and come out with a negative number? No. So the hypotenuse is always positive. That might be confusing when you get, something like this. I don't know. The hypotenuse is the positive one. It doesn't matter which of these. So let's just talk about the fraction real quick. So I'm allowed to put the subtraction sign here. I'm allowed to put it here or here. Those are all 3 viable places to put the subtraction sign. And the numerator and the denominator are out front. All of those are okay. All right. Let's go back to our little negative 5, 2. So I'm going to write out sine theta, and right next to it I'm going to write cosecant. It's reciprocal, just to make my life easier. And then I'm going to write cosine theta, and then secant theta. Then I'm going to write tangent theta, and then cotangent theta. Okay, so we just need to read the, SOHCAHTOA off the triangle. So sine is opposite over hypotenuse, so 2 over root 29. Now, in all likelihood, your book will probably want you to rationalize. On any test or anything, you do not have to rationalize, but the book probably will. So let's remind ourselves how to rationalize. I'll just put it over here. So 2 over root 29. Remember, how do we rationalize? What do? We multiply by,
Root 29.
yep, root 29 over root 29. That's what we do. 2 times root 29 is 2 root 29, and root 29 times root 29 is 29. So these answers are equivalent. One is rationalized and the other is not. But they're the same. They're the same number. Your book should ask you to rationalize or not. We'll see when we get to the homework. So for cosecant, we're just going to flip it upside down. So it's root 29 over 2. Okay, great. So cosine, let's see, cosine is adjacent over hypotenuse. So -5 over root 29. That means secant would be negative root 29 over 5. Okay, good. Tangent. Tangent is opposite over adjacent, so 2 over -5. So flip it upside down, -5 over 2. And that's what it wants us to do. Okay, how are we doing? Okay, great. All right, so let's draw this triangle. We're in quadrant 3, so let's just draw a triangle in quadrant 3. Okay, let's see, this is theta. Theta, by the way, theta is always the angle that's right by the origin. It's never any, it's always right by the origin, okay? It's that right in the middle. That's where theta is. So let's see, sine is opposite over hypotenuse. We know the hypotenuse can never be negative, so we know that obviously the 2 has to be negative. Okay, so to get our third side, we do our Pythagorean. So we've got -2 squared plus b squared equals 3 squared. So b squared is what, 9. Move the 4 over, so 5. So this is square root of 5. Now, I have to pay attention to what quadrant I'm in. That is an x-coordinate. Is the square root of 5 positive in the third quadrant?
No.
No. So I have to know to put the subtraction sign, the negative there. I have to know that. Okay, my work with Pythag is not going to tell me that. It's always going to give me a positive number. I have to know that that's negative. All right, so now all we have to do is read all 6 trig functions off of that triangle. Same scenario as the problem above, same thing. So let's just write it out, sine, and then we'll put its little reciprocal by it, cosecant, cosine, and secant, tangent, and cotangent. So to be honest, we only read like sine, cosine, and tangent off the triangle, then we just flip them upside down, right? That's all we do. Okay, so sine is opposite. Ooh, it's going to be -2 over negative root 5. What would that make the final answer? Positive. It'd be positive. So I'm going to erase those negatives. So it actually would be, it'd have to be 2 over root 5. So cosecant would be, oops, the hypotenuse is 3. I'm so goofy. 3. I don't know, I was going crazy over there. I was doing tangent or cotangent. So sine they already gave us is -2/3. Cosecant, we'll just flip it upside down, -3/2. Cosine. Cosine is adjacent over hypotenuse. So adjacent over hypotenuse. Secant, we flip it upside down. Tangent is opposite over adjacent, so it's going to be 2 over root 5 because the negatives cancel. Opposite over adjacent, and cotangent would be just the flip. Whew. Once you get the triangle done, the numbers should not be too bad. Okay, how are we doing? Okay, so that is our 6 trig functions with that criteria. All right, let's move over to number 3. On number 3, we've got unit circle values to calculate, so we're going to just draw our little thing. Let's see, 2 pi over 3 is 4 pi over 6, so 1, 2, 3, 4. It's right here. It's tall. Okay, it's tall, so is sine going to be 1/2 or root 3 over 2? It's tall. Sine is y. Yep, root 3 over 2. Root 3 over 2, and that's a positive. It's positive in that quadrant, right? Sine is positive in the second quadrant. Okay, cosine, 5 pi over 6, 1, 2, 3, 4, 5. It's long down here. So it's long along the x-axis, and so right above it. Sine is y, cosine is x. So it's long along the x-axis, so that's root 3 over 2. Is cosine or x positive or negative in the second quadrant? It's negative, right? X is negative over there. Okay, minus. All right, let's do this again. So you've got 2 pi over 3, which would be 4. 1, 2, 3, 4 pi over 6. So it's tall. Since it's tall and it's x, it's going to be 1/2. It's going to be short. And negative because this is x is negative in the second quadrant. I'm going to pause here for a second and make sure I'm not going too fast. Is everybody okay? Okay. Last one. Sine of 5 pi over 6, 1, 2, 3, 4, 5. So it's here. Sine is y. Okay, so it's short. The y value is short, so that's going to be 1/2. And it's in the second quadrant, so it's positive. All right, whew, that was a lot of work to get those numbers down. We read them all off the unit circle, and that's where I want you to eventually be. I want you to be able to draw those and figure out what the value is. Okay? So now it's just a matter of arithmetic. So root 3 times root 3 is 3. Positive times negative is negative. 2 times 2 is 4. Okay. 1 times 1 is 1. 2 times 2 is 4. A negative times a negative is a positive. Okay. So we've got negative 3/4 plus 1/4. Oh, yay, they have the same denominator. Don't have to mess with that, ladies. That's great. Negative 3/4 plus 1/4. Let's see, negative 3 plus, so that's negative 2/4, which reduces to negative 1/2. Whew, that's a lot for negative 1/2. Okay, one more problem, and it's a word problem. Yay! Y'all are like, oh my gosh, stop it with the word problems. We gotta have word problems. They help us apply stuff. I know students really typically don't like word problems, but that's okay. This is not a bad one. Not bad. Let's read it. So we have a rain gutter is to be constructed of aluminum sheets 12 inches wide. After marking off a length of 4 inches from each side, the length is bent up at an angle of theta. Okay, so let me just say, this is a similar start to a calculus problem. We need to understand the mechanics of it. Okay, so I'm not really that great at folding. You're going to have to be with me here. So I have a piece of paper. Okay, so this is 12 inches. Okay, 12 inches. We're this way, 12 inches, okay? And it's bent up. So you take it and you bend it up on either side. What shape does that make? It's flat on the bottom and it's bent up on the side. What shape You think about this being a top, what does that make?
Take it as this one.
Trapezoid. Trapezoid. Actually, it would be a rectangular prism if it was up this at 90 degrees. Yes, absolutely. But I don't think, we're not told it's 90 degrees, so we're not sure. So we're gonna go with this. Is that okay? Oh, so we see. Now the great thing is, we don't even have to know that. I just need you to understand, because look, this is like the best word problem ever, because they want us to find the area and they give us the formula. Look, this is the formula. Wow. Okay. That's the formula for area. We don't have to do anything except they want to, let's say, if they want to tell us that theta is 30 degrees. Well, okay, that's fine. Let's just plug into the formula. So A of 30 degrees is 16 sine of 30 degrees times cosine of 30 degrees plus 1. Okay, just unit circle stuff. It's fine. We got this. Let's see, 30 degrees. Let's draw that out. So 30 degrees would be right here. So sine is y, so that would be shorter. Y is shorter, so this would be a half. And then multiply cosine of 30 degrees. Let's see, it's longer along the x, so that's going to be root 3 over 2 plus 1. Then, all we can really do, 16 times a half is 8. 8 times root 3 over 2 plus 1. That's my answer, unless I have a calculator and they want me to do decimal. That's all I would do. We can't do root 3 over 2 plus 1 without a calculator. That's really not a thing. And that's it. How are we doing?
What was the purpose of